All right, last topic is some properties unique to our solids. All right, so quick review from what we've been discussing before, just to kind of make sure we've got this down for solids. So what are solids going to have? High or low kinetic energy? Hopefully you said low. All right, solids have very little motion in their molecules. That's what makes them stay close together and stay in solid form. Which then kind of also answers the next one. If it's low kinetic energy, we're going to have low motion. How about our intermolecular forces? Are the molecules close together and attracted to each other, or are they spread out and far away? All right, you're going to have high intermolecular forces. All right, molecular mass. All right, that ties into your kinetic energy. Things with big molecular mass are slow and clunky, so they are going to be more likely to be a solid. And then your shape-wise, if something is very linear and it can line up right next to each other really close, which is going to enhance its intermolecular forces, then that would make something more likely to be solid. So some characteristics of solids just in general is there's two major ways of classifying solids. We've got crystalline solids that have very organized repeating patterns, and we'll talk about what these kind of look like in a little bit more detail. But your examples of these are things like diamonds, gemstones, quartz, sugar, salt. All right, they have very defined structures and patterns to how their molecules line up. And then you have amorphous solids, which have a much less regular structure, and you can almost think of them as like frozen liquids. So they can even sometimes maintain some of their liquid-like properties in terms of being able to be kind of moved and maybe flow a little bit. To me, the greatest example of this is going to be something like rubber. Like you can bend it and move it around and change its shape without breaking it, sort of thing. But glass, plastic, and rubber are examples of amorphous solids. Another thing you want to be familiar with, and I would definitely, make sure you're familiar with some of these examples, things like that, is the different sort of bonds and the characteristics of these bonds when it comes to crystals. So your crystalline solids can be ionic, all right? The table salt is probably the most common example you can familiarize yourself with, but essentially anytime you combine a positive ion and a negative ion in an ionic bond, all right? And then the characteristics of ionic bonds is that they are super strong. They are the strongest of all of these. They are the hardest, the brittlest. They have the highest melting points, all right? So I'm going to even add ists on here. All right. And then on their own, they actually have poor conductivity. Covalent network are strongly covalently bonded atoms to each other, and these can be things like what's in diamond and quartz. All right, they are also hard and brittle, but not quite as much as our ionic bonds. They also have really high melting points and boiling points, but not as high as our ionic bonds. And then they too also have either absolutely zero or very low conductivity. Your metallic bonds, all right, are what you think of when you think metal. So iron, copper, silver, gold, platinum, all right. These definitely have some malleability. You can bend and shape them. Melting points vary from low to high. And then these guys are unique because they have their high conductivity. And then your covalent molecular bonds are going to be things like glucose or sugars. All right. They are softer, so less brittle, more just closer to the side of malleable. They have low melting points and also have no conductivity. And then the last thing you got to be familiar with is this concept of the unit cell. And this is what gives crystalline solids their uniform and very organized structure. All right, so if you're looking at that, this is an example of table salt, NaCl. All right, so you've got little NaCl, NaCl alternating atoms. All right, some stuff that you can kind of note from this picture is the angles between all of these. All right, they're all 90-degree or right angles. All right, and then how would you describe the distance between each atom? All right, are they changing? Is it always the same? And it's always the same. So it's this very uniform structure.